Right, I wanted to finish up this section by looking at some common terms that are often mistaken for each other. The first of these we've talked about already. Asteroid is a large rocky object moving through space. A meteoroid is a smaller, and by smaller and larger here, we don't necessarily have a good distinction between the two, but they're basically just smaller asteroids that are rocky objects moving through space. A meteor, as I mentioned before, is a rocky object or a piece of comet material that's burning up as it moves through the Earth's atmosphere. And so this is also what we called before a shooting star, even though they're not stars. So the technical definition then for a meteor is only satisfied if it is burning up as it moves through the Earth's atmosphere due to friction. And then a meteorite is a meteor that's able to make it all the way to the Earth's surface without completely burning up. And only a small minority of meteors make it to the Earth's surface. These are usually made of iron. And are not rocky if they make it to the Earth's surface. The reason for this is that rocky objects are easier to burn up due to friction as the object moves through the Earth's atmosphere. And so sometimes you can feel a shock wave due to objects that never even hit the surface. There was this huge disaster back in 1906 in Siberia where for many, many miles, trees were leveled, and it was just a disastrous kind of an event. And there was some kind of a meteor that was observed in the vicinity. You heard a huge cracking sound of kind of like a sonic boom from this thing. And finally, a decade or two later, they decided to do an investigation and try to find the crater. And they couldn't find the crater. There was no crater. And they finally concluded that it was a shock wave and that the object had never actually made it to the Earth's surface. But for objects that do make it to the Earth's surface, the best defined crater that we have on the surface of the Earth is Meteor Crater. And this is in Arizona, a little bit east of Flagstaff, and it's really worth seeing if you get a chance. This thing is about 1 mile in diameter, but the size of the iron meteorite that caused this thing to form was no bigger than the size of a football stadium. And so we might wonder then, well, how is it that something that's so small can make such a huge crater? And the answer is, it's because of all the energy. And that energy can turn that solid object into a gas. And gases take up much larger amount of volume than the solid does. And they also have a tremendous amount of energy that can be released in a collision like this. And so this, again, has to do with the fact that kinetic energy goes like the square of the velocity. And so if these things are moving fast enough, they hit the surface, they have a huge amount of energy contained within them. And so this is, as I said, the freshest new meteor impact that's significant in size on the surface of the Earth. It's something like 30 to 40,000 years old. Now, when we look at meteorites, we generally see things that have a high amount of metal in their composition, but only about 5% of meteors are metallic. And so we're selectively seeing that small percentage that doesn't quite burn up on its way into the Earth's surface. But going back to this meteor crater, Barringer is the guy who owned this crater, and he bought it with the idea that he was going to make a lot of money with an iron mine, because he figured this would have a lot of iron in it, and so they could just mine the crater for iron. And when they started digging into the crater, they found no iron at all. It turned out it had been vaporized and scattered over miles and miles of terrain. And so there was nothing left for Barringer to do but to turn it into a tourist attraction. And so that serves its purpose very well, and is something that I recommend that you go see if you're in that area east of Flagstaff in Arizona.